Friends, in the previous class we have studied about the different kind of crystalline solid based on the nature of forces acting between the constituent particles. As we have studied, based on the nature of force acting between the constituent particles, they are categorized into four types. The first one molecular solids, the next ionic, the next is metallic, and the next is covalent and network solid. In that class, we have discussed about the nature of graphite. Graphite, diamond, both are network solids, covalent network solid. We know in that case, they have repeating units of carbon atom, unending network of carbon atom. We know diamond is brittle. We know diamond is non-conductor, whereas graphite, it is conductor, it is soft, diamond is hard. We know graphite is conductor because of having free electrons in a carbon atom which will conduct in a definite layer, not in between the two layers. It means the conductance of graphite is good in case of a single layer, but it is poor in case of two layers. Let us now discuss the type of lattices. What are lattices? We know in case of crystalline solids, there is regular repeating arrangement of atoms or particles in the three-dimensional space. Then what do you mean by lattice? Let us discuss what is lattice. Then after that we will discuss what is crystal lattice, and to the next one we will discuss what is unit cell. The first one we will discuss what is lattice. If you know what is lattice? Lattice, it is the point in three-dimensional space. We know there are three dimensions, x, y, and z. It means lattice, these are the point in three-dimensional space where atom sits. Right? That is known as lattice, lattice point or lattice site. What do we call it as? Lattice. It is an array of points in three-dimensional space. To the next one, if you want to know what is crystal lattice means in a crystalline solid which have a regular repeating arrangement, the arrangement of atom, particles or ion in three-dimensional space gives the crystal lattice. The next one is crystal lattice. Crystal lattice, the arrangement of particles in three-dimensional space gives space represents diagrammatically then, and if the arrangement of particle in the three-dimensional space represent diagrammatically, then in which the particle is depicted as point is called crystal lattice. Let us discuss what is the difference between the lattice and what is the difference lattice and what is crystal lattice. Lattice, these are the sites, spaces where atom sits. Clear? What is lattice? Lattice, it is the area of point in three-dimensional space. It means the points where the point in the three-dimensional space where atom sits, that is known as lattice. Whereas crystal lattice, it means when the points or the particle sits in the crystal lattice in the three-dimensional space, it forms the crystal lattice. Clear? To the next one. There are 14 possible arrangement of points in a space known as Bezier lattice. It means if we are going to arrange the points or the particle in three-dimensional space, then we have 14 such possible arrangements. It means if we are going to arrange the point in three-dimensional space, then we have 14 possible arrangements, and that is termed as Bezier lattice. What are the characteristics of Bezier lattice? We will discuss. The characteristic of Bezier lattice. The first one, it means each point in the lattice is known as lattice point or lattice site. The first one, each point in the lattice is called lattice site or lattice point. The next one, in the lattice, each point or each side is occupied by either atoms or molecules or ions. The next is that each point in the lattice is occupied by atoms, ions or molecules. To the next one. If we are going to join each point in the given crystal lattice, then we get the structure of that particular substance. It means if we join the points in the crystal lattice we get the structure. What we know? If you know lattice, it means it is the point in three-dimensional space. The point in three-dimensional space, or we call it as lattice site. It means it is the vacant position in three-dimensional space where atom sits to give the crystal lattice. It means the vacant position in three-dimensional space is known as lattice. So the next one, crystal lattice, it means when the atom sits, atoms, ion or molecule sits in the lattice point, it gives the crystal lattice. To the next one, we know if we are going to arrange the point in the different manners, then 14 such possible arrangements are there, which are known as 14 possible arrangements are there, which are known as Gravis lattice. What are the characteristics of Gravis lattice? The first one is that each point in the space is termed as lattice site or lattice point. It means each point in the three-dimensional space is termed as lattice site or lattice point. To the next one, each site, at each site we may consider it may be atom, it may be ion, it may be molecule. Clear? To the next one, if we join the lattice point, lattice site, then we got the structure of that particular substance. Clear? Let us discuss the next point, that is known as unit cell. What is unit cell? In a crystal, a unit cell is the smallest repeating unit. As you know, it is synonymous to the bricks. When bricks repeat itself, it gives the structure of the building. In the same way, when bricks repeat itself, it gives the shape of a building. In the same way, in case of crystalline substances, the unit cell is the smallest repeating unit. It means when it repeats itself again and again, it gives the entire crystal lattice. It means what we got? Unit cell, it is the smallest. It is the smallest repeating unit of the crystal lattice. To the next, what are the characteristics of the unit cell? Let us discuss. Characteristics. Characteristic of unit cell. A unit cell is characterized by two things. The first one is the edges and the next one is the angle between the edges. The edges, the first one, edges, they are represented by A, B and C. The next one, the angle between the edges. Angle between the edges. They are represented by alpha, beta and gamma. Let us discuss what is alpha, beta and gamma. Let us draw the unit cell. How we will represent the sides and how we will represent the angles between the sides. Let us see. This one is A, side A, this one is B and this one is C. Let us represent the side A, B and C. And to the next we will represent the angle. This one is alpha. This one is beta, and this one is the gamma. Let us see. Alpha is the angle between B and C. Side B and C. To the next one. Beta is the angle between A and C. Beta is the angle between A and C. A and C. To the next one. Gamma is the angle between A and B. A and B. What we studied? We have studied unit cell. Unit cell, it means it is the smallest repeating unit. When it repeats itself, it keeps the entire structure. To the next, we have discussed the characteristic of unit cell. A unit cell is characterized by two parameters. One is the side. They are A, B and C. And the next one is the angle. That is alpha, beta and gamma. We have discussed if these are the sides P, I have represented the side in the back side as dotted line. If this one is the side B, this one is C and this one is A. Then alpha is the angle between B and C. Beta is the angle between A and C. And gamma is the angle between A and B. These are the characteristic of unit cell. To the next, unit cell is categorized into two broad categories. That is, unit cell. It is categorized into two broad categories. The first one is primitive unit cell. The next one is centered. The next one is centered. We are discussing the unit cell is broadly categorized into two types: primitive unit cell, and the next one is centered unit cell. With the first one, we will discuss the primitive unit cell. In primitive unit cell, the atoms are present at only at the corners of the cube. Let us represent it. If this represents the unit cell, then in this type of unit cell, the atoms are only present. I am going to represent 3D figure on the board. It will somewhat difficult to you to understand, but I will try my best so that you can understand. This dotted line represents the line in the backward side. In this unit cell, the atoms are present only at the corner. Let us see. It means if you suppose your room to be unit cell, it means in case of primitive unit cell, if the atoms are only present at their corners. How many corners are there in your room? 8 corners. It means we represent the primitive unit cell in this way. Clear? To the next one, if we discuss centered unit cell, then centered unit cell is further categorized into, the first one is known as body centered The next one is face center, and the next one is and center. We have discussed in case of primitive unit cell, the atoms are only and only present at the corner of the cube. Whereas in case of body center, the atoms are present at the corners of the cube together with one atom at the center of the body. Let us represent. In case of body center, see here. In case of body center, as the name indicates, body center, it means one atom. One atom is located at the center of the cube. This is the cube. One atom is located at the center of the cube. This one is the center of the cube. Together, they have the atom at their 8 corners also. It means in body center cube, the atoms are present at the corners of each corner together with one atom at the center of the cube. Let us represent. This is the figure of body centered unit cell. This one is primitive unit cell, body centered unit cell. So you can see here what we see, that atoms are present at the corner of each cube. Clear? The atoms are present at each corner together with one atom at the body center. Therefore, it is termed as body-centered unit cell. To the next, we will discuss face-centered unit cell. Let us represent it.